Hello friends, we'll start from this question number 21 in this lecture. In this question, we have to find V2 and V1. Okay, now we can see that first of all, I will just paste the image here. Now, it's a very simple question. Now, since this 4 ohms and 4 ohms are parallel to each other, the voltage drop across these two will be similar. And since the current in this 4 amperes, 4 ohms is I amperes, so the current in this will also be I because they are parallel to each other and voltage drop has to be same. Okay. Now, at node A, we can see that the incoming current is 5 ampere, the outgoing current is I ampere, outgoing is I and outgoing is 2I. So nodal at node A KCL, the incoming current is 5 ampere, outgoing is I plus 2I. So I is equal to 5 by 4 amperes, right? Okay. One more thing, we can easily see that V1 voltage, since these three elements are parallel to each other, so the voltage across these will be similar. So since 4 ohm 4 ohm and 2I dependent source are parallel, so the voltages across them will be same. So I can say that V1 is equal to 4I, that is 4 into 5 by 4, that is 5 volts. Okay, so V1 is known to us now. Now I will just paste this figure again. Now we have to find V2. Okay, now to find V2, we know that in this branch the current is 5 ampere. To find V2, we will apply KVL loop in this loop. Okay, the loop name is, this is node A, this is B, and this is C. Okay, so the C A B C is the loop. Okay, now from C to A, since the current is flowing from left to right, the voltage will be positive in left and negative in right. So it is 20 volt. Voltage drop across 4 ohms is positive at top, negative at bottom, and is it equal to V1? And V1 we know it is equal to 5 volts. Okay, and from B to C, we know that we will enter the V2 voltage at minus terminal. So it will be negative while writing the mesh equation or the loop equation or the KVL equation. Okay, so from C to A it is plus 20, from A to B it is plus 5, from B to C it is minus V2 is equal to 0. So V2 is equal to 25 volts. Okay, so a simple KCL will give us V1 and a simple KVL will give us, sorry, a simple a simple KCL has given us V1 and a simple KVL has given us V2. Okay, so this finishes the question. Now let's move on to the next question, that is this question number 22. Okay, so in this we have to find Vx is equals to question mark. Now first of all I will just copy this figure. Now what all given it to us, first of all we will mark that. Okay, so it is given that the voltage drop across this is 0.25 Vx. Okay, the voltage drop across this is Vx. Let us assume that this is grounded. This voltage is, this potential, this whole node is at ground potential. So this will be at Vx. This is at 0.25 Vx. So the voltage drop across this is 0.75 Vx. Okay. Now, okay, so let us assume that this whole node is A, this is B, this is C. Okay, so there are three nodes here. We have to find Bx. Okay, okay, so we have to find Bx. Now, at node A, at node B, sorry, at node B, the incoming current is 5 amperes. The outgoing current is 0.5 Bx. So the current in this branch, I will just zoom it, will be 5 minus 0.5 Bx. Okay. Now the current in 20 ohm resistance will be Vx divided by 20, that is 0.05 Vx. Okay. So in this branch, the current will be the 10 ohm. Okay. So in 10 ohm resistance, the current will be 5 minus 0.5 Vx minus 0.05 Vx. Okay, so from where we are getting this result, I will tell you again. Okay, so the method that you have to apply is like the combination of KCL and KVLs. Okay, does not always restrict yourself to nodal analysis or mesh analysis. Okay, because this is a gate exam, you don't have to solve the question theoretically, like you don't have to solve the question in a conventional manner. Okay, you don't have to give the solution, the whole solution. You just have to mark the answer correctly. So KVL and KCL combined will solve the question in a very fast and the simple manner. For example, here, first of all, I have marked all the voltages that is visible to me. Then at node B, I applied KCL. The incoming current is 5 amperes, the outgoing current is 0.5 Vx. So in this branch, the current is 5 minus 0.5 Vx. Okay. In 20 ohms, the current will be Vx divided by 20, that is 0.05 Vx. So the current in 10 ohm resistance will be 5 minus 0.5 minus 0.05 Vx. That is 5 minus 0.55 Vx. Now, as we know that the voltage drop across 10 ohm resistance is 0.75 Vx. So I can say that current multiplied by 10 ohm is equal to the voltage drop, that is 0.75 Vx. So the current is 5 minus 0.55 Vx multiplied by 10 is equal to 0.75 Vx. 50 is equal to 0.75 Vx plus 5.5 Vx. So Vx is equal to 50 divided by 5.5 plus 0.75. Okay, so easily you can solve the question. That is 50 divided by 6.25, and you can get answer, that is 8 volts. Okay, so this is the kind of solution that I would prefer, and I have always used such kind of question, such kind of method while solving any gate exams. Okay, so I would always prefer that you should use KCL and KVL in a combined manner for gate exam. Okay, you do not have to restrict yourself to a mesh or nodal analysis, as we have seen in this question. Okay, now another question, question number 23. A very simple question, and we have already seen the concept of this question earlier. Okay, so we have to find the power dissipated in power delivered by 5 volt source. Okay, so this source. Okay, so first of all, let me copy it, paste it. Okay, now, okay, so as we know that this network and this network will always satisfy KCL, that is incoming current has to be equal to outgoing current. So since this is a resistance which has a 6 volt drop across it, so the current will be 2 ampere in this direction from right to left. Similarly here, the current will be from left to right 1 ampere, because positive current always flow from positive to negative in a resistance. Okay, so 2 ampere is given by network 2 in this branch. 1 ampere is received by network 2 by this second branch. So to satisfy KCL at network N2, current should be like this 1 ampere, because 2 ampere is going out, 1 ampere is entering here. So how much current should enter from the third branch? 1 ampere to satisfy KCL. So simple concepts that actually I have already told you in the previous videos. So this is a simple concept that is being used here also. Now 5 volt source, if you concentrate at this 5 volt source, the current is actually flowing out of the positive terminal. Out of the positive terminal, the current is flowing out of the positive terminal. So power is supplied, and power supplied is equal to I into V, that is 5 volts into 1 ampere, that is 5 watt. Okay, okay. So whenever, I have already told you this, but I am again repeating it, whenever the current enters from the positive terminal, then the power is absorbed by the element. For example, this resistance is absorbing power, but whenever any element is supplying power, then current has to go out of the positive terminal. Okay, so remember this. Okay, so we will be continuing from question number 24 in the next lecture video. Thank you.